Okay, so today we're going to review on how to solve equations with variables on only one side. Okay, so the vocab that I'm going to be talking about throughout the day is equation, which means it shows two expressions that are equal, hence the word equa in the front from Latin. The solution is a value that makes the equation true when substituted. Okay, commutative property means that if you're adding, you could just flip the numbers. So for an example would be 2 plus 5 is equal to 5 plus 2, right? Because, that does not look like a plus. 2 plus 5 is 7, and 5 plus 2 is 7, so they're equal, okay? It also can be with multiplication. 2 times 5 is 10, and 5 times 2 is 10. You also, lastly, we're going to have is associative property. That means that if you just look at it, this has a pair of parentheses. Think about it when you're at school and you have a certain amount of friends, you like to talk to someone, and then you mix it up. Well, these little parentheses represent groups. So these are individual groups that you're going to be working together. All right, so let's get down to business. Okay, so we're going to do an example of evaluating. So we're going to evaluate the expression to check if x is a solution. Okay, so here's the problem. We have 2 plus 4 times x minus 1 equals 22 if x equals 6. Okay, so basically they're saying, here's this equation that I'm giving you. Here's what I think x is. Prove to me that I'm right. So how do I prove that in? I'm going to substitute it in. I'm going to plug it in. So this means that whenever I see an x, I'm going to replace it with 6. So let's do that. This 6 right here is going to replace this x right here. So let's do 2 plus 4. I'm going to use blue because that's what we're going to represent for 6. 6 minus 1 equals 22. Okay, so all I did was I took that 6 and I plugged that in for x. So now we're going to go by order of operations. So we're now going to do always inside the parentheses. So 6 minus 1 is 5. And I know I write really big. It's just a bad habit. Okay. 4 times 5 is 20. And then add them up. Well, doggone it, it matches, so yes, it is a solution. So if it just says x is a solution, that just means to plug it in. You are not solving. Unless it says the word solving, you do not solve for anything. Okay, let's try solving now. Okay, so before we go into solving, I'm just going to go over some quick statement. Inverse operations. Okay, what I mean by that is when I'm adding, the inverse is going to be subtract. When I'm subtracting, the inverse is going to be adding. Okay? When I'm multiplying, my inverse is dividing. When I'm dividing, the inverse is multiplying. This is key. If you see an addition, you're going to subtract. If you see a subtraction, you're going to add. When you see a multiply, you're going to divide. When you see a dividing, you're going to multiply. So I'm going to show you what I mean by doing some examples. But that is key. If you mess that up, it's going to bite you in the butt, and then you're going to get really mad because you get the wrong. So let's try this. Okay. Here's my first example. I'm going to do a simple one. 2x minus 3 equals 13. Okay, so I'm subtracting 3, and my goal on these problems is to get x by itself. I don't want anything else next to it. So, I see is subtracting. So now, opposite of subtracting is adding, so I'm going to add 3. Now, what I do to one side, I do to the other. I like to think of this as a mirror. You more likely also have heard of it as a wall. I think of it as a mirror because what you do to one side, the mirror reflects on the other side. Okay, so I'm going to add 3 on both sides, and we get 16 equals 2x. Alright, so now what do we need to do? Well, we need to get x by itself. We got 2 times x right here, so now I'm going to divide by 2, because dividing is the opposite. And now we have x equals 8. We're done. Now, how do I check my work? Here's the thing about me. Don't ask me if the answer is right because you can check it yourself. So I'm going to show you how to do that. So you're going to do the original problem. Let me do it in the same color so you don't get confused. 2x minus 3 is equal to 13. So I now know x is 8. So I'm going to do 2 times 8 minus 3 should equal 13. Because remember, in our first example that we did, this is saying that this is a solution. So in order for it to be a solution, we can plug it in. So 2 times 8 is 16 minus 3 should be 13. Well, 16 minus 3 is certainly 13. So we did this right. Okay, so let's go on to another one. Alright, so here's example 2. I'm going to bring in a negative 15x minus 6 equals 1. Okay, so now we're subtracting 6. What's the opposite of subtracting? We're going to add 6. Let me make my mirror. So now we have 7 equals negative 15x. Okay, so now this negative 15 is being multiplied, so now I'm going to divide by negative 15. Do not forget that sign. If you forget that sign, it's going to mess you up. So now we have x equals negative 7 over 15. Okay. So now, here is when a lot of teachers get picky on, and I understand why. You can keep it as a fraction, or you can put it as a decimal. If you put it as a decimal, you need to have it in 3 places. If you don't have it in 3 3 numbers, then it's going to mess you up when you go into higher math. So let's do this. So in a decimal, okay, so this is equal to 0.46666. We want 3 decimal spaces, so it's going to be 0.467. That is my answer. Now, if you do not round and you put it as a decimal, I will not give you full credit. If you leave it as a fraction, I will give you full credit. Alright, let's do another problem. Alright, so this problem has a problem with decimals. So we're going to do 9.1. Oh, this is going to be example C. Now, I do letters, so you can use numbers. I just don't want to do numbers and anything as part of the problem. So 9.1x minus 3.5x equals 10.5 minus 2.8. Alright, so what do we got to do first? Well, we got x's on the left and we got numbers on the right. Don't think this is a really hard problem. It really isn't. So we got x's. We are first going to combine like terms. That means that every single family that you have an x with, you're going to combine those. So that's only on the left side. Okay, that's only on this side. I don't care about the right. So let's do this. Okay, so now we have 9.1 minus 3.5, which is 5.6x on the left. So now let's do the right. So now we have 10.5 minus 2.8, which is equal to 7.7. Okay, because we can combine these. So let's keep solving. This is have a decimal in front. I'm going to divide by 5.6. So now x is equal to 1.375. And I'm done. Okay, so now we're going to do one more problem, and then we're going to do a word problem, and then we are done. Okay, so now we got x divided by 7 plus 3 equals 15. Okay, now, I know you guys hate fractions, but I'm going to show you a trick. This right here is our denominator that's on the bottom. One student said it was the demon that lives on the bottom. I don't agree with them. But anyways, that number, I don't want to get rid of it. It's being divided. Well, what do we say the opposite of division was? Well, it's multiplication. So that means I'm going to multiply everything by that number. Okay? Not just one thing. I'm going to multiply everything. When you multiply, since multiplying and dividing are opposites, these are going to cancel. So now we have x plus 21 equals 105. All right, are we done? Almost. We got to move that. We're going to make our mirror. Got to move 21 over. Now we have x equals 84. See? That was easy. We got a fraction, but we're not going to worry about it. One last problem. Okay, so now we have this problem. Julio has $5 more than Dan. Altogether, Julio and Dan have $19. How much money does each young man have? Okay, so what do we think is important here? Well, $5 more is key. So I'm going to highlight that or circle it. And we know we have $19. Okay, so let D represent the amount of money in dollars that Dan has. Use D to write an expression that represents the amount of money that Julio has. Okay, so D, so I'm going to write it. Now this just sounds like a lot of blah. All this is saying is D equals amount of money Dan has. So when you see these problems, let me write it this way. When you see these problems, as soon as you see a variable, highlight it, and this is what it means. So we don't know how much money Dan has, but we do know that Julio has 5 more than Dan. So 5 more than, okay, more dollars means addition. Because if you think about it, if Dan has $4, Julio's going to have 9. If Dan has $15, Julio's going to have 20. So Julio is our goal. So Julio, we want to know how much Julio has. So if Dan has $5, so let's do this with numbers and with variable. So if Julio has $15, we know that Dan, and we always know that we have to add $5 to Dan. What does Dan have to have? If Julio has $20, well, what does Dan have to have there? Well, for $15, Dan has to have, well, $10. For $20, Dan has to have 15, right? Because we're going to add 5 to whatever we have to our new total. So Julio, in this case, would be D plus 5. That is Julio, okay? So we know what Julio is. Now we know part A. So part A is done. All right, so part B, we want to know how much money does each of them have. We know in the second sentence that Julio and Dan have $19. So I'm going to write that in words. Julio plus Dan equal $19. Well, based on part A, we know that Julio is D plus 5. And we know in the problem, D is how much money has. We're going to put D equals 19. Well, hold up. This looks like the problems we've been doing all along, so let's keep going. Okay, so we got d plus 5 plus d is 10. So I'm going to get rid of those parentheses so you can see what I am doing. So I'm going to erase these. Oh, I guess they don't like to be erased. So I'm going to rewrite it without the parentheses. And see how I have two d's on the left-hand side? Now remember, if you do not see a number, the coefficient in front is a 1. Okay, so 1d plus 1d is, well, 2d plus 5 equals 19. Well, we got to make that mirror because we got to solve for d. So we got adding 5. We're going to subtract 5 to both sides because that's the inverse. So now we have 14 is equal to 2d. How to get rid of multiplying by 2? Well, we're going to divide by 2. So now we know d is equal to 7.